It's been a long time, but welcome back. It's finally time to start building Roku, so let's get on with the frame assembly. I will see you on the other side. My name is Ben Stineman, and I started Rotor Visual back in 2015 to focus on developing and operating commercial unmanned aerial systems, or drones. In late 2019, it felt like it was time to go big, and I began designing a new aircraft capable of lifting pretty much any camera system. So join me on this journey as I document the process of building a massive drone. Before we get into the build, let's go back to the CAD model and go over some of the key features and components of the airframe. We'll begin with the assembly of the main center hub, which consists of a 4mm carbon fiber bottom plate, 6 CNC machined aluminum root arm brackets, as well as a 4mm carbon fiber top plate. There will be some footage of the cutting and drilling prep of the 35mm carbon fiber tubing that makes up the offset arms, followed by their assembly, including the routing of motor wiring and installation into the central airframe hub. We will round out this video of the build process with prep, assembly, and installation footage of the fixed landing gear brackets and struts. As mentioned back in video number 2 on the frame design, the frame plates were drawn in Fusion 360 and then machined by Armatan Productions out of 4mm flat carbon stock. The arm root brackets are anodized CNC machined aluminum sourced from a vendor online. The bolts for the arm roots are ISO 7380 M4 black oxide alloy steel button head bolts with a tensile strength rating of 140,000 psi. Loctite 243 blue thread locker is being applied to the bolt threads, which for the uninformed is essentially an adhesive to prevent threaded fasteners from loosening due to vibration. The forward and aft root brackets are getting 4 of their 6 bolts installed. The midpoint bolts in the pattern are being left out in order to attach the fixed landing gear plates later. The port and starboard wing roots are getting all 6 bolts. The top plate is only temporarily attached here, as the power and avionics trays still need to be installed. Cutting the 35mm carbon tubing for the arms with a miter saw may not be the ideal method, but using a new 80-tooth 12-inch carbide finish carpentry blade proved to be very effective in giving a very clean cut as long as the blade feed was slow and deliberate. I was able to clean up the cut edges with 220 grit sanding sponge. A quick note. Though not pictured here in the footage, I was fully decked out in PPE during the cutting and sanding of the carbon fiber parts, including a dual N95 respirator, safety goggles, and some sweet MaxiFlex gloves, most of the time. The overhead door was also open in the shop, providing a ton of airflow to dissipate the harmful carbon fiber dust. After sanding, I used the air compressor to blast the dust off of all of the parts. Drilling carbon fiber can be tricky. I ended up selecting carbide brad point boring bits to drill both the arm bolt and cable passage holes. I used a wooden dowel inside the carbon tube as a backer to minimize tear out. To prepare for arm assembly, I am putting black oxide washers on 55mm M3 18/8 stainless button head cap screws for the offset brackets. The Hobbywing X-Rotor X8 Pro motor has 12-gauge power wires and a ribbon cable for ESC control and telemetry. These cables will route through the tubing into the central hub of the airframe. Here, I'm sliding on some TechFlex braided sleeving to protect the cable from wearing on the carbon fiber edge as it passes through the outer arm side hole inside the offset bracket. The offset bracket plates are machined from 2mm carbon fiber plate by Armatan Productions and give the arm the ability to fold over the top of its adjacent hinge while also providing a 2-degree tilt upward. Aluminum clamping brackets specifically for 35mm OD tubing provide a solid connection between the components. The assembly is fastened using steel M3 spring-style lock washers. Thread locker may be applied to these later after flight testing. Another TechFlex mesh sleeve is used for the cable passage through the arm hinge. M4 stainless bolts are used to prevent the tube from rotating or completely pulling out of the clamp in flight. Aligning the tube in the offset bracket and hinges is critical for the cable passage holes and mounting bolts that pass through the aluminum parts, as well as general alignment of the entire airframe. I am using a few methods to accomplish the alignment. The first one is using the flat surfaces of the bracket components and the LED light bar on the bottom of the motor against the bench to rotate the roll axis of each part around the tube. Once aligned, the clamping bolts can be tightened. I will then use bubble levels on the flat surfaces of the arm parts to compare alignment to the frame. The arms are clamped and through bolted into the root arm brackets on the central airframe hub. The motor cabling will route under the central avionics tray, which will be installed in the future. Roku will have several options for landing gear. Gimbals with built-in landing struts will be most commonly used, but for now, fixed struts are being installed. Fixed struts can be useful in stationary non-gimbal payloads like LiDAR or thermal imagers. The aluminum adapter plates for the angled landing strut brackets were laser cut by sendcutsend.com. A slight change in the design was made after the fact so that these could be attached by 2 M4 bolts instead of using all 6 going through the bottom 4mm plate into the arm bracket. Larger 8mm holes were drilled into the 4 corners of each plate and deburred with a large countersink bit. The strut brackets are assembled with M3 bolts and thread locker. With the airframe on a stand, the 25mm carbon tube struts can be attached quickly with 2 14mm M4 bolts per plate. The feet for the struts were modeled in Fusion 360 and 3D printed in PETG filament. It's always rewarding to see a design go from CAD model to real life. The scale of this thing became more and more apparent as it came together. It's a monster. Let's go over some of the real-world stats. The frame with fixed landing struts and the motors with props weigh in at 13 kilograms, or a little over 28 pounds. The diameter between the motor shafts comes in at around 1710 millimeters, or about 5'7" inches. When the 765 millimeter or 30-inch propellers are installed, that stretches out to a whopping 2390 millimeters, or about 7'10" inches. The next video will be about electronics and wiring. If you have any questions, leave them below in the comments. Thank you for watching. Please subscribe if you haven't already so you don't miss out. And I will see you in the next one. Bye.